Hello, welcome back. We're going to solve LeetCode problem 1584, minimum cost to connect all the points. We're given a set of points on a 2D plane. The cost of connecting these 2 points is the Manhattan distance between the 2 points. So we're given the formula for the Manhattan distance. Our job is to return the minimum cost to connect all the points. Now, a note on Manhattan distance. The Manhattan distance between 2 points is the distance calculated by taking the sum of the absolute distance between x and y coordinates. In this example, between these 2 points, the Manhattan distance is 3 plus 4. So the Manhattan distance is 7 in this case. Now going back to the problem, our job is to find the minimum Manhattan distance to connect all the points. Our approach is to use Prim's algorithm. If you're not familiar with Prim's algorithm, I have a long discussion on Prim's algorithm in part 1 of this series. The link to that video is in the description below. Please check it out before continue with this one. The general approach is to build a minimum spanning tree to connect all the points. We start with, say, 0, 0 as the starting point. We will find the distance between 0, 0 and all the other points of the graph. And then we will select the point that is closest to 0, 0. And in this case, it is 2, 2. So we add this edge. Next, we will find the Manhattan distance between the points on the minimum spanning tree, which is currently 0, 0 and 2, 2. And we'll find the distance between these 2 points and all the other points on the graph. And then we will select the points that's closest to the points that's currently on the tree. So in this case, the point is 5, 2, and we will add this to the tree. Again, we will repeat this process and find the Manhattan distance that's closest to points on the minimum spanning tree. So the next closest point is 7, 0. And then finally, we will include 3, 10. Now we understand how we're going to build minimum spanning tree. Let's do this in code. This C# code is provided in the GitHub links below. First, I will initiate 2 data structures. First is a heap or priority queue, where we will store the tuple that includes the points and the weight. The weight here is the Manhattan distance between that point and a point on the current minimum spanning tree. Just to highlight this a little bit more, as we are building up the minimum spanning tree, the heap stores all the points that are not on the tree and their distance to some points on the tree. So in this way, when we use the heap, we can always select the points that are closest to some points on the existing MST. The other data structure I will initialize is a hash set where I will store all the points that are currently in the MST. To start off, I will put the first point on the heap. So the first point is 0, 0 and the weight is 0. Next, I will dequeue the 0, 0 point and add this point to the visited set. And then I will find the Manhattan distance between 0, 0 and all the other points that are outside of the MST. All the points together with their Manhattan distance to point 0, 0 will be packaged in tuples and to be placed on the heap. This way, the top of the heap will be the point that is closest to the point 0, 0. In this case, it's the point 2, 2 that is at the top of the heap. Next, I will dequeue the point 2, 2. And I will add 0.22 to the hash set. And I will update the value of 4 in the total variable. Next, I would compute the Manhattan distance between 2, 2 and all the other points that are currently not on the MST. All this information will be also placed on the heap. So currently on the heap, we have all the Manhattan distance between every point outside of the MST and this point 0, 0. And also to the point 2, 2. Then next, we'll pick the point that's closest to either 0, 0 or 2, 2. And in this example, it will be 5, 2. We continue to iterate this process, and as we build up the MST, we will continue to update the total value. At the end, we will turn this as the minimum Manhattan distance to connect all the points on the graph. Okay, let's take a look if this works. And it looks good. So next time, we will explore a different algorithm for MSTs. Hope to see you then.